Hi everyone, today I'm going to be talking about large-scale cluster management with Ansible.
What's your name?
My name's Albert Autin. Ronan.
Right there.
Yeah, it's on the screen. I've been working with the trade desk for about a year now, and I've been working with Aerospike for 4 years. I am active on the Aerospike forums a lot. If you want to come there, ask some questions, I'll probably be responding to you in a day or two, unless the staff get to you first. My username under there would be Albot. But at the trade desk, I'm mainly responsible for deploying, monitoring, maintaining, and designing and optimizing for Aerospike. Aerospike's been a great product for us because of the speed and scale it can operate at. So this is the agenda that I'll be going through. I'm going to talk a little bit about Aerospike at the trade desk, what our deployment looks like, and some kind of boring stuff for people who are already using Aerospike and working with it every day, Aerospike maintenance. But I want to include a little bit of background for people who are not working with Aerospike every day. What does maintenance look like? What is maintenance for? Costs, pitfalls, and risks of doing that maintenance. And finally, automating all of that using Ansible. You probably saw this yesterday when Matt Cochran did his presentation. But just to summarize, the Trade Desk is an ad tech company. We're a demand-side platform, and we have a lot of scale, and we use Aerospike. And the Trade Desk is the best company in the world. This is the global Aerospike footprint at the Trade Desk. I think this is one of the, if not the largest footprint in either number of servers or data footprint, one of those. So we have 17 clusters, and as of this week, more than 10 data centers. We have over 500 systems deployed, most of those bare metal, some of those cloud. Not very much Kubernetes yet. And we have over 3 petabytes of NVMe storage allocated. That's not how much we're using, that's how much we're allocating, and over 140 terabytes. So we have a lot of systems to manage. So that can be pretty challenging to manage all those systems running Aerospike. So maintenance tasks. Managing Aerospike, you're going to end up doing these sooner or later. So I guess one of the questions I'd like to ask is, has anyone ever had to do any of these here? Just Jason. Okay. What do all of these tasks have in common, or what do they cause in the cluster? Migrations. I wanted this in big bloody text, but it didn't render. So for anyone managing Aerospike, they're intimately familiar and probably a little scared of this word. There's pitfalls to this process. It can be pretty taxing, but it's a necessary evil for any distributed database. You have to have re-replication. You have to have a way for data to move within a distributed database. So just quickly, why are migrations important? What are they? Anytime the original data distribution of a cluster is disturbed, migrations will kick in. That's the process that Aerospike calls, that it does to move around the data, re-replicate the data. So this is an animation showing what happens if we lose a node in Aerospike. So before I kick off the next animation, this was a 4-node cluster, and we have a total of 4 records, and we're running a replication factor of 2. So if we lose a node in this configuration, we now are in kind of a vulnerable state where record Y and record Z now only have 1 copy. So the cluster will actually recognize that, and then it'll move over, rather copy that data to other nodes to bring up its replication factor. And something similar happens when we add a node. A node comes in, the cluster recognizes it, and it shuffles the data around. And both of these operations are handled through migrations. So migrations are important because they bring up our replication factor and they help distribute our load across the cluster. So sooner or later, we're going to have to wait for migrations, is kind of the message I'm trying to send. This is not always the case. You don't always have to wait for migrations if you're using persistence on disk. And if you're using tombstones or your company can handle certain scenarios, there's a lot of reasons why you might not necessarily have to wait for migrations, but you're going to have to wait for migrations sooner or later. If you have a storage format change like in 4.2, or if you're using in-memory configuration of the namespaces, or if you're replacing systems or you have new wiped drives, you're going to have to wait for migrations because that data has to be re-replicated and moved over if you take a system down and bring it back up, or if you're just adding new systems. So what's the big deal with migration? So as we talked about before, it's obviously important because it handles distributing your data and re-replicating your data. And when a cluster's in having migrations, it can be in kind of a vulnerable state. As I kind of showed earlier, when we took down that system, it was in a vulnerable state because 2 of those records only had 1 copy in the cluster. So if we were to lose another node before those records got copied over again, we'd have data loss at that period of time. And in not much earlier versions of Aerospike, taking a system down for maintenance was handled just like a node loss. So quiescense was recently released, I think 4.3.1, and this alleviates some of this risk of doing maintenance. So we no longer have to do maintenance, and when we take down a system, it's handled the same as a sudden node loss, and we have the risk of if another node fails, we have data loss. So that's helpful, but we also have a human risk here. If this process isn't, if you don't wait for migrations before taking down another system, you can have data loss. So you can also have the risk of speeding up migrations too much. So in some cases, I would argue that the human risk of doing maintenance is probably the most dangerous thing about running Aerospike. It runs unless you touch it and you do something wrong to it, then you might run into trouble. And migrations are time consuming. They require a lot of time depending on your deployment. If you have very large systems, it can take hours for migrations to complete. And they can be very taxing on your system. Because if each system is handling terabytes and millions of records and the system goes down and that data has to be now re-replicated, that's a lot of tax on the system. So to further illustrate what the potentially dangerous effects of throttling up, or I guess I would say speeding up migrations too much, I created this. This is a test cluster, and we have 4 nodes. One of them isn't shown here. One of them was just used to send load using the benchmark utility. And this is really just a 3-node cluster. So we have a node that I restarted. That's the blue line here. And that node was coming in empty. And these other 2 systems, they had all the data. So when we add a system to the Aerospike cluster, that should spread our load out more evenly and reduce our load, right? We're spreading that out. We're scaling. So it should be a good thing. But if you're giving too much priority to migrations, it can really not be a good thing. You can completely overload the cluster by giving too much priority to migrations. So if we allow migrations to use too many resources, it can be problematic. And in this example, we have that one node coming in empty and the 2 nodes sending it data. And because I had it sped up too much, the disk became overloaded, the CPU went well over the core count, the load average at least. And our latency shot up, our network throughput shot up. And this is just a single node coming into, this is just forming a 3-node cluster. If you have 90 nodes trying to send data to 1 node coming in, this could be, it could just kill it. So migration tunings are nice. You can reduce your time to do maintenance by speeding these up. And instead of waiting 6 or 8 or 20 hours between taking down a system and bringing it back in, you could reduce that to an hour or 2 hours. So it can be pretty valuable to speed up migrations and to tune these migrations, but of course within reason. The defaults are a good place to start, but you really need to keep a good eye on your resources and be careful about increasing migrations too much, because you want to make sure that you have available resources to continue serving your clients, to allow your application to continue working. And if you speed up migrations too much, your cluster could actually fall apart. The heartbeats could be missed. It could split out into separate clusters. or you could crash a node. So it can be dangerous to speed up migrations too much, but it's kind of something that we all do because waiting 10 hours between restarting a node is not very desirable, especially at the scale that we're at. So this might be a bit of an exaggeration. So suppose you had a deployment of 500 systems. And at the trade desk, we have more than 500 systems. And maybe they take 2 hours or 8 hours for migrations between each system. And in most cases, whoever's doing this maintenance isn't going to be watching this happen, like a system coming down, coming back in, migrations are happening. They're not going to be watching that 24/7. So this may be a bit of an exaggeration. But if you're speeding things up enough, your cluster can be in a pretty vulnerable state. So you may be keeping some good amount of attention on your cluster. So just to exaggerate a little bit, assuming you were speeding up things as fast as they possibly could go, what would the cost of maintenance look like? And this is a number, but really the more disturbing thing is how bored this person is going to be. Let's just be honest. So yeah, there's a cost, but really if this guy is just spending his entire job taking down servers and watching migrations and trying to make sure that his cluster's not falling apart and his application's working, he's not going to stay. So there's different ways to do upgrades. You can bring the entire cluster down. That'll be easy. You can just take the whole thing down, upgrade it, and then bring it back, and everything will be fine. But if you're globally operated demand-side platform, or if you have any kind of business where you have to have all your systems up 24/7, there's not a great time for taking your entire cluster down. There's also a high risk of a good majority of those systems not coming back. So if you take down 100 systems and then you found out that something you did or the way that you patched the systems, 50 of those don't come back up, you might be in trouble. And then, of course, you run the same problems of anytime you don't wait for migrations and you're not using tombstoning, and you don't have the way to reload that data. You could have data inconsistencies if you're reloading from persistent disks. There's a bunch of risks with it. It's usually not worth it. We could also do this in batches of 10%. So if you had a 100-node cluster, do 10 at a time. You could wait for migrations between taking down each system. That's probably a safer way to do it. But if you do that, then if you're sized like right at the edge of your deployment, then if you're taking down 10 of those systems, then the remaining 90, or whatever your cluster size is, will start to evict data so that it can all fit in that 90-node cluster. So then you start throwing out data early where maybe you didn't want to do that, and each time you take down one of those systems, you're causing proxies and evictions. It can be a bit stressful in the cluster. And you run the same problem with, or the same risks as taking the entire thing down. Not as large, of course, but if you're taking down 10% of your cluster at once, you still run the risk of a certain number of those not coming back. So there's numerous reasons why you wouldn't want to do either of those. Pretty much everyone sticks with rolling upgrades. So we take down one system at a time, do the work on it, bring it back up.
If you do the batches, you probably want to be using quiz, or you have your rack work set up where it's like batches.
Yeah, but you still run the risk of, if you're not sized to handle it with 10% less systems.
No, but you said you suggested that as an option, but just make sure that people know you can't just take down 10 nodes if your replication vector is less than 10.
Yeah. Well, you could if you're using persistence. It's just your data will be missing part of the time, and then it'll come back. Hopefully, there's all kinds of problems with it, right? There's lots of problems with it. Talk to Kevin if you have more questions. So at the scale we operate at, we really needed a better way to do this. We couldn't do all this manually. We needed a system that performed upgrades idempotently in an automated fashion that was reliable and could scale with us. So we use Chef for our configuration management and Ansible for task orchestration. This may eventually change to all Ansible, but I'm personally a fan of Ruby. I like Ruby, so I'm hoping we can stick with Chef. We'll see. So we like Chef for configuration management. This includes creating configuration files, installing, managing, tuning some services, and grabbing all of our binary files. Chef is nice for us because it's easy to write changes into. We can inherit cookbooks, say like for a security cookbook, that can be inherited to all of our other cookbooks, and for a sudo cookbook. It's really nice to be able to share all those different cookbooks and recipes and such between all the applications. And for creating a specialized cookbook for Aerospike, it wasn't too far off. Brian did most of the work for that, though. Chef is nice for that because we can create Ruby templates, Ruby libraries for dynamically creating partition schemes or dealing with a certain environment like AWS, creating special configurations just for that. So it's nice to be able to use Ruby and Chef to create our configuration files and drop all of our binary files. But Chef doesn't really have a great way to do Aerospike installs. If we told Chef, hey, install the latest version of Aerospike on all these systems, it would just do them all at once. For a distributed database, you don't really want to take them all down at once because you're going to cause all kinds of interruptions. You're going to have those risks. So we like to use Ansible for that. So Ansible we like to use for one-off tasks or tasks that require more complexity than Chef can offer. I'm sure people could do more complex things with Chef, but out of the box, Ansible just fit this better. And Ansible has a lot of built-in modules and systems and ways to perform maintenance that we felt was just too good to pass up. Now we use Ansible for setting up our new systems. We use it for decommissioning systems, upgrading systems, performing backups, all kinds of different things. So for anyone not familiar with Ansible, this is kind of what a playbook looks like. It's written in plain text YAML. And a playbook usually begins with a few properties. The name of the playbook, which host you're going to target. And one of the key things here is serial 1 on the third line in this Vim screenshot. And that means do these things on one host at a time. So if we gave Ansible a list of 100 hosts, it would do all of these tasks, one node at a time. And Ansible does have ways just to run ad hoc commands like a distributed shell command, but Playbooks is really where Ansible shines. So in this playbook, we're just to illustrate what a playbook will look like, this is just grabbing the version of Aerospike in a variable. It's going to print it out to the terminal, and then it's going to install a Python module. And it's actually doing that using the pip module built into Ansible, which has its own set of logic and functions built into it. So we're not using the shell there. We're using the Ansible pip module, which has a whole bunch of other complex logic and functions and checks and everything built into it. So it's nice to be able to do that. So now that we've covered maintenance, steps, pitfalls, problems, and the cost of doing all that manually, how do we automate this? The main requirement is that we need a way to not only manage the systems, we need a way to upgrade the kernel, of course, install and uninstall software, ensure that the server is healthy, but we also need a way to choreograph Aerospike migrations with all that. So is this server okay to take down? Does it have migrations going on? Is the cluster healthy? What's the cluster size? So we wanted to integrate something with one of these configuration management or DevOps tools with that, and really all of them can manage that, but none of these solutions have a way to integrate with Aerospike built into them already. So we wanted to do this with Ansible. So in Q3 or Q4, we had to replace 200 systems. The Trade Desk has a lot of advertising opportunities towards the end of the year. We have holidays coming up. There's the end of fiscal year. So there's a relatively big traffic spike towards the end of the year. And we needed to be ready for this traffic spike. The problem was some of our most important clusters were already at over 100 nodes, 115 nodes in one of the clusters. And Aerospike supposedly only scales to 128 nodes for now. I'm not sure if I believe that. But we needed a lot more capacity, and it was recommended that we scaled out horizontally. So we had to scale up vertically. So this meant we had to replace 200 physical systems, or over 200 physical systems. We had to keep everything online because we're still running 24/7. The ramp-up's already happening. And each one of these systems had 10, 20 terabytes of data on them. This wasn't a quick process. So we started doing this manually, and we eventually got to the date. We finished it out in 2 months before the biggest spikes were to come, and it went well. But it was really painful. And about a month into the project, we started developing a way to automate this. At first, this was a bash script, and then a Ruby script, and then a Ruby script that an Ansible Playbook could execute, and then it was a Ruby Ansible module. And at a certain point, I found that we couldn't actually publish Ruby Ansible modules to core, and I really wanted this to be something that we could all be able to use, because I think part of the frustration with this is we've all built this. We've all built a way to do this. If we're operating at any measurable scale, over 20 systems, we're all writing our own ways to do this. So I really wanted a way to share what we've done with the rest of the community so we could all build on that and all reap the rewards from having that shared. So I rewrote this quickly as Python. Disclaimer, it is my first Python script. And after fighting with the Ansible guys for a little while, it is merged into Ansible core. So if anyone is using Ansible as of 2.8, you will have an Aerospike migrations module built into it. So if you're using Ansible today, you just type that thing in, put in the required arguments, and you have a way to choreograph your Aerospike upgrades, decommissions, numerous things. So because we had this now, we had a module that could help us choreograph this. We could just create a limited inventory or a list of hosts to decommission and point this playbook at it. And it would run through the hosts, do all the necessary steps to make sure we were still up and operating and we didn't have any data loss. And it would send us a Slack message at the end of it. So the last month went a lot smoother. So this is what an upgrade using Ansible would look like. It's pretty much the same steps you would do if you were doing it manually. And I am going to share the playbook here and how you can get the module and everything later on. But I just wanted to emphasize again that the most important thing here is we have serial one, meaning this playbook executes all of these steps at one host at a time before moving to the next one. All of them have to be successful. And we have a way to check for migrations and cluster size. So I do have a demo. It's 10 minutes long. I'm not going to bore you with the entire thing. It's a 4-node VM cluster. They're all just running locally. They're running. Skip step 5? Huh? Let's see, what is step 5? Wait for migrations? Yeah, we could have done that. Okay. So in this demo, if anyone doesn't believe me that it's actually checking all the things, I listed the number of records for our namespaces here. I am using 4.3.1.3 because it does allow quiesce, which makes things easier. We do have clusters that are running older versions, and this module does work with those. I made it backwards compatible. As far back as I know that Aerospike goes, maybe it'll even work with Citrus. So in this demo, we have these 3 namespaces. We have 4 nodes. These nodes can take kernel updates, and I place the Aerospike server enterprise tar file in the /vagrant folder. In production, we actually have Chef drop this into a folder for us to use. But just for demo sakes, that's where it is. So this is the demo I have recorded. These are all, again, local VMs. And this is AMC on the right. If anyone's not familiar with this is Aerospace management console. It's a pretty GUI. So it shows the versions that Aerospace run and the nodes and the record counts here. And on the left, I just have my playbook command. So I have my Ansible playbook command. I have my inventory I'm pointing it towards. And then I have the playbook. I'm passing that as an argument. And then I have a few variables I'm passing in. I want to say, yeah, go ahead and grab Linux updates. And I want you to install this Aerospike version. And you can log in as root because everyone runs as root, right? So let's see, is it going?
It's going really slowly.
Okay, that was short. This is a video, I swear it is. Does anyone here know how to use a computer? All right, this was supposed to take up like 10 minutes of this talk, so we're going to be done pretty soon here. I would really like to show this. I'm getting the spinny like arrow wheel.
I think those are the migrations.
It's like a 400 megabyte video. I don't know why. Yeah, it is. Yeah, it's always a good thing to have a 600 megabyte PowerPoint file, right? So, well, in case this doesn't play, I'm going to run a single command. It's going to iterate through these systems, upgrade them one at a time. Hey, is it? Okay. All right, don't touch it. Yeah. So this is going to be following the same steps that I listed out earlier, the same steps anyone would do, really. They would log on to a system. Well, maybe they wouldn't log on to each and every system, but logs on the system, checks to see if it's eligible for an upgrade. We don't really want to touch the system if it's already upgraded. And so right here we have a little, just a debugging output. It's saying, yeah, this is running 4.3.1.3. There's a version compare library built in Ansible, so you can check the versions. And it says, yeah, we can upgrade this. And so then it has a whole separate block for what to do if it's upgradable. So then I'll either copy the package out or whatever. In this case, it's going to quiesce the node and then run the recluster command using asadm. In previous versions, you wouldn't be able to do this. You would just kill the node after checking for migrations, and then, or if you didn't have, if you had some systems where the replication factor was just 1, you would need to run an AS backup command. We have some playbooks that do that. Anyways, so it's just going through this cluster and doing the work for me. So instead of me manually logging in, running these commands, and hoping I do everything right, or hoping that I wrote these commands and a list of steps that my coworker can follow correctly, we just have a playbook that'll go through and iterate through these hosts and follow all these steps and checks and do the upgrade for me. So since we're running AMC on this system, and it actually got a kernel upgrade, AMC died, so I had to refresh it. I guess you're wondering what's going on here. So our first node upgraded, it's on 4.5.1.5 now. And it joined the cluster again. Now it's waiting for migrations. And once it's done waiting for migrations, then it'll upgrade the next node and continue on until it's done. So we have a playbook that'll upgrade this cluster now. And no one has to go through the pain of doing it or making sure they're doing it right. So now the question on everyone's mind should be, what happens if something goes wrong? Because you're giving the reins of your maintenance to a script or a program or a module. And that can be pretty scary if Aerospike's integrated into your critical business components. So Ansible has its own set of error handling, exception handling, and you can control a lot of that for all of its various modules and such. And I think the default behavior is that if any error is detected, it'll just abort the entire thing. So if we have a serial 1 set up and we're targeting 100 hosts to do something on, and an error is detected, it'll just stop. Like if it's on the 10th host and something went wrong, it'll stop. It won't go to the 11th. And if something's wrong, it won't just keep breaking them on all of your systems until it's done breaking your entire cluster. It'll stop. And then you can go look at the reason for failure and run it again. And if you have integration with the AWX and Slack, it'll Slack it to you and say, hey, something went wrong. And we have a few different checks built into it. The module does check a lot of things. It makes sure that all the various statistics are present, make sure that you're running the right cluster size, there's a migration. Migrates are allowed, the cluster key is good, all that good stuff. But the rest of the checks are really built into Ansible. Like we want to verify the versions there, we want to verify the server's up. And Aerospike's running. There's a service module built into Ansible where we can check the service status and such. I did want to show, this is another video I'll probably play though. What happens when we run the same playbook on a cluster that's already been upgraded. Because we already have, the first step is to grab the version and check to see if we want to upgrade it. It should just skip all of these. And it does still log into each host and check that version, and then it skips all the tasks. But if you were running this playbook on like a 100-node cluster and it aborted on the 30th node, say your Wi-Fi broke, you're running it from your laptop or whatever, that wouldn't be fun if it tried to upgrade those first 30 nodes again. So that's why that check is built into there, to where it'll just skip through the ones that are already worked on and then finally get to the one that's not been worked on and do the upgrade. So I want to quickly talk about AWX. AWX is a web-based interface for Ansible. It's also called Ansible Tower. I think AWX is the open source version. I'm not sure if it's supported by Red Hat. I think it is. AWX is nice because we can schedule things to run. It runs on a server, not a laptop. We can delegate permissions, and we can delegate who can run this playbook. So we don't actually have to have an operator execute this playbook or look into the failure messages. We could just have, we could build the playbook, upload it to AWX, and give someone permission to run it. AWX also has reporting. It'll centralize all the reporting of what playbooks are running, when did it fail, the logs. It'll also centralize all of our credentials, and it checks out our playbooks from source control. And we also have, I think it was one of the funnest features, is that Slack integration. Although we could probably replace it with the Python script if we wanted to, but it's just really nifty. Because we have a system, a server that's just dedicated to running playbooks, and we can schedule those, and it's just great to have something that can do that for us. But typically we do run these locally first as just regular Ansible playbooks before pushing them out to AWX. This is a screenshot of one of our AWX jobs. This was, let's see how much time I have. Yeah, we're good. Okay. Aerospike released a version of the Aerospike tools. It was like a second slower when we called it. And this actually caused a lot of problems for us because we had some old tooling that would call asinfo like 20 times. And that caused timeouts, and it was a huge mess. We since replaced all that with the Prometheus monitoring stack. But this playbook had to be executed a lot of times and on a lot of hosts, and we just wanted to have it up in AWX. We probably could have done this with Chef, but it's a good example of what AWX looks like. This is the web GUI for AWX. This is the screen you get after you execute a playbook, or if you're looking at a playbook status. It gives you the job template, and right here's the log and the entire output. You can download it or scroll through it. And at the bottom here, we did have this integrated with Slack. This is the Slack notification it sent us once it was done. And it just sends us the name of the playbook and a link to the job. So I want to go a bit into the Aerospike migration module. Again, this is going to be present in Ansible 2.8 and forward. This is what it looks like if you're using it. So this is how you would implement it into your own playbook when you're writing your list of tasks for Ansible to perform. You can put it in the playbook before you take Aerospike down, check to make sure that all this is correct. We want to make sure that we're at this certain cluster size and there's no migrations and everything's okay. Before we go on, the curly braces here, like on fail and cluster change, that first one, that's a variable that you can pass into the playbook, so you can dynamically control the behavior of the playbook. So for a certain AWX template, I may be able to want to run that AWX template in one environment with different variables than another environment. For example, a very large cluster we have may take 20 hours for migrations between each system, and some of them only take 2 hours. So this can be useful to tweak as you're running it. So if you want to use the module before 2.8 comes out, you can just grab the Python script. It's just some plain text. There's nothing crazy looking. And you can place that in your Ansible plugin path or your AWX library path. And I have a GitHub repo that I just quickly tossed together and contains the playbook that I used to upgrade this test cluster. I didn't include the code to build the test cluster. I'm assuming that everyone here has knowledge or has a cluster that they already have that they may want to run this on. But it's not too bad to get running. I think there are some Vagrant playbooks out there already. Not playbooks, Vagrant files that can set up Aerospike already. But if you want to look at what we're doing with the demo here, you can download or clone or just look at that GitHub repo. It has everything in there, including the Python library. These are all of the different parameters that the module takes. When you are including this module into your Ansible playbook, there are some things that you will have to pass, and there are some defaults that you can change. I guess I'll go through these. We have time. The consecutive good checks, we can pass that. So we want to make sure that Aerospike has looked good 3 times in a row before continuing. I'm a little paranoid about my cluster. I don't know if anyone else is, but I want to make sure it looks good 3 times in a row with 60-second breaks in between before I do anything to it. Fail and cluster change. If we're watching the cluster after we did something and something changed, let's support the playbook. Something weird happened. I have 2 minutes. Okay, I thought I had like 10. All right. Migrate RX keystring and TX keystring. These are just the default statistics that we monitor. The Aerospike reports if you have migrations incoming or outgoing. And just for crazy backwards compatibility, and because Aerospike likes to rename things sometimes because they're mean, you can pass those in. And this is how it works. This is kind of the main loop. So it verifies the cluster is in a good state. By that, I mean the cluster key is being reported the exact same across all the nodes. So they all think they're part of the same atomic cluster. They're all saying that we are this cluster size, and that's what you pass in as the minimum, and that migrates are allowed. These are all checks to prevent you from continuing if the node that you're looking for migrations on or that you happen to get statistics from is part of a split brain cluster. It'd be really bad to continue breaking apart your cluster automatically. So there's a lot of good checks in place. Aerospike recently released a cluster stable command that does a lot of this. And it checks for all these different edge cases and makes sure that there's no migrations and such. The Aerospike migrations module does detect if your entire cluster supports this command. And even if you're upgrading 100 nodes and 50 of them can support this, and once you get past the number of old nodes, once it detects that all the nodes can support this, it'll automatically switch to preferring this. And yeah, it's not perfect. There's a lot of things to be done with it that I'd like to do. Some of the optimizations I made with it kind of break after 4.5.2. Like if you wanted to check for local only. So if a system has if you have a 100 node cluster and one particular system that you want to take down doesn't have any TX or RX migrations pending, but the rest of the cluster does, it might be safe to take that down. And it doesn't support TLS. And again, I'm not a super great Python programmer. So there's a lot of things that could be done with it, but part of the reason I wanted to publish this is that we're all creating this stuff. We have all created our own Java program or C# program or Bash script or Corn Shell script. I've seen so many permutations of ways to handle this problem. And none of them are really published online. I think we're all kind of waiting for Aerospike to throw something out for us to use as a operational way to choreograph and manage operations. But yeah, this is now published. So anyone can check out the Ansible core repo and make changes to this, look at it, modify it, use it locally, or submit a PR. If anyone wants to be added to the maintainers list, please. Please ask. And if you want to get in touch with me, I'm really active on the forums. You can always reach out there. I don't think the Aerospike guys would mind too much. Or reach out on GitHub on the Ansible repo. I think that's it. All right, I have 30 seconds for questions. 28. Oh, I do? Okay. Oh, okay. I didn't know I was going to get paddle boards with timing. So that's news to me. I thought I had like 15. I was like, oh, okay. All right. So any questions?
What was the event in your operational task that led to you wanting to check your free time?
I'm just paranoid. That's it. That's all. I think it's unnecessary, but that's why it's a parameter. You can change it. You can change it to 1. It's fine if you want to do that.
Didn't we see migrations drop to 0 and then come back up every once in a while?
Oh, I know.
Really old versions of prior to 3.13.
Okay.
Kevin has a reason. Old versions are weird. There you go.
Actually, it's older than that. So sorry, but it is part of 3.6.
No, I don't know. Okay. Nothing else? Okay.
This is good. Okay, so if we have quiescence now,
Yeah.
would you sort of have an option, add an option to just not wait for migrations? Right?
Well, you still wait. Like he had replication factor 1, so you still wait
Yeah.
for that to migrate during quiescence.
Assuming replication.
The demo has quiesce, kind of. What?
Assuming replication factor 2, do you really want to wait for migrations to end every single time?
I mean, it completely depends on your use case, right? Are you using tombstoning? Do you care about stale records? Are you using persistence? Like, there's a ton of questions that go along with that.
Are you going to add like a quiescence only?
I would like to add a lot of features to it, but that's why it's published, so you can work on it now, right? I got some of the guts out there, but there's a lot to be done with it, It doesn't support checking for a particular namespace. Like maybe we only want to wait for migrations for this one namespace, or this list of namespaces, or maybe we want to add quiesce to it. I don't know. There's a lot of different things that could be done with it, but the core bits of it are there, and it works.
Yeah.
What are you doing with all that free time that you generate?
So I consider just playing video games, but I like to work too much, so writing other playbooks, that's what I've been doing. And, standing up more Aerospike, mainly. Yes?
Do you have a checklist
No, I think I don't have a checklist, but it's really, if anyone wants to work on something, just work on it. Maybe I should. I'm not sure. This is the first thing I've merged into Ansible. Don't have very much experience there, but I think TLS is probably one of the most important things. There's some pretty basic, very important things I should add to this that just weren't immediately relevant. So it would probably become very obvious if you looked at it and this didn't meet some of your requirements. But it's pretty straightforward the way the Aerospike uses their info protocol and the way to work with Aerospike, that adding something like that shouldn't be too difficult. Okay. Thanks, guys.